Welcome to next lecture. In this lecture, I am going to solve example of double integrals by changing it into polar coordinates. Okay. Before we start, just let me explain one simple thing that we have to keep this simple basic things in mind while we are changing our Cartesian coordinates to polar coordinates. Okay. We are changing here. Changing into polar means what? We are changing Cartesian to polar. Okay. Here in the example we will be given with Cartesian means x and y, polar means we need to change them to r and theta. We change here x to r and we represent y by theta. Okay. Here the replacing the limits by x by r and y by theta. As you know, while we converting Cartesian to polar, we used to take x as r cos theta, okay, y as r sin theta, and x square plus y square is equal to r square. Okay, this is the equation of a circle, and theta is an angle. Also, we'll get dx and dy. Dx into dy will be r into dr d theta. These are the basic things we need to remember. Okay. ಏನ್ ಮಾಡ್ತೀರಿ, ಕಾರ್ಟೇಶಿಯನ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇರ್ತಾವೆ ಎಕ್ಸ್ ಅಂಡ್ ವೈ ಇರ್ತಾವೆ. ಎಕ್ಸ್ ಅಂಡ್ ವೈ ನ ನಾವು ಪೋಲಾರ್ ಫಾರ್ಮಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಎಕ್ಸ್ ಲಿಮಿಟ್ಸ್ ನ ಆರ್ ಅಂತ ಮಾಡ್ತೀವಿ, ವೈ ಲಿಮಿಟ್ ನ ಟೀಟಾ ಅಂತ ಮಾಡ್ತೀವಿ. ಎಕ್ಸ್ ಇಂದಲ್ಲಿ ನೀವು ಆರ್ ಕಾಸ್ ಟೀಟಾ ತಗೋತೀರಿ, ವೈ ಇಂದಲ್ಲಿ ಆರ್ ಸೈನ್ ಟೀಟಾ ತಗೋಬೇಕು. ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ವೈ ಸ್ಕ್ವೇರ್ ಅಂದ್ರೆ ಆರ್ ಸ್ಕ್ವೇರ್. ಇದು ಸರ್ಕಲ್ ವಿತ್ ರೇಡಿಯಸ್ ಆರ್ ಅನ್ನ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ. ಸಪೋಸ್ ದಿಸ್ ಇಸ್ ಯುವರ್ ಸರ್ಕಲ್. ಯಾವ ರೀತಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಆರ್ ಅಂದ್ರೆ ಏನು, ಇಟ್ ಇಸ್ ಅ ರೇಡಿಯಸ್ ವೆಕ್ಟರ್. ಇಟ್ ವೇರೀಸ್ ಫ್ರಮ್ here 0 to up to r. This is our radius. Okay, like this it varies. And theta heng measure ಮಾಡ್ತೀರಿ ಅಂದ್ರೆ theta is, it starts from this here and moves like this. Okay, in anti-clockwise direction. Theta we have to measure like this. Yes. Okay, now we'll see this example and then you'll come to know how to change the Cartesian to polar and evaluate such examples. Now the example is given as limit integration, double integration from 0 to 1 and 0 to root 1 minus y square, x square plus y square dx into dy. Okay, this is our example. Let this be I. Now the limits, here we have a dx and dy. That's why these limits y 0 to 1. So this represents y 0 to 1 and x 0 to square root of 1 minus y square. Function is x square plus y square into dx dy. Now we have y varies from 0 to 1. Okay, y is 0 and y is 1, and x is equal to 0 and x is equal to root 1 minus y square. So root 1 minus y square equal to x means what? When you square this, what we'll get? So this gives us x square equal to 1 minus y square. What it implies? X square plus y square equal to 1. But we know x square plus y square equal to r square. What it implies? R square equal to 1. This represents r square equal to 1. That is r is equal to 1. So when x is 0, then r is, when x and y both are 0, r is equal to 0. When x and y both are 0, r is equal to 0, and r reaches, what is the maximum value? 1. So r is equal to 1. So r varies from 0 to 1. So we done with the x coordinate. Means x, we converted x to r. R varies from 0 to 1. Now as I said, y represents our angle theta. Okay. Now y is 0. So theta is 0. Okay. It starts from 0 only. But since for this For us, x square plus y square equal to 1. For this example, we have got a x square plus y square equal to 1 because we need to find the region of integration. Okay. So this is a unit circle. Okay. Radius is r, r as 1. So this is called the unit circle. So let us draw. This is a unit circle, means what? With radius r equal to 1. Okay. Radius r equal to 1. This is our unit circle. This represents x square plus y square equal to 1. Okay. Now it is a 0. So r where starts from 0 and ends at 1, means what it implies. So this is 1, this is 1, this is 1, this is 1. Okay, unit circle. So our region of integration is what? This portion, means in the first quadrant. Okay, so first quadrant is the region of our integration. So r varies from 0 to 1. And what about theta? As I said, we have to measure the angle keeping the angle here only. Okay, from x-axis we have to start from here. So as in the first quadrant, how much angle we cover? We cover 90 degree. That's why y varies from, that is a theta varies from 0 to pi by 2. Okay, we have got to both the limits. Now substitute in I. So we'll get I as integration. Replace y coordinate by theta, that is 0 to pi by 2, and x by r is equal to, r varies from 0 to 1. Now what about x square plus y square? As you know, x square plus y square is r square. It is r square into dx dy. Dx dy is r into dr dt. So this is theta 0 to 1, pi by 2, and now r cubed dr into d theta. Okay, we'll write one more step. R varies from 0 to 1, r cube dr into d theta. So this is equal to theta from 0 to pi by 2. When you integrate r cube, you will get r raised to 4 by 4. Limits varies from 0 to 1 into d theta. So this is theta 0 to pi by 2. 1 by 4 is a constant. Now upper and lower limits when you apply, so it is 1 minus 0 into d theta. That is integration from theta 0 to pi by 2. You will get it as 1 by 4 d theta. Therefore, now integrate with respect to theta. So I equal to 1 by 4 is a constant. Integration of d theta is theta. So theta varies from 0 to pi by 2. So this is 1 by 4. Apply upper limit and lower limit is here 0. So it is pi by 2. So I equal to pi by 8. The solution of the given double integral, when you change the coordinates to a Cartesian coordinate to polar coordinate, the value is pi by 8. This is how to simplify the given double integral by changing the polar coordinates. Okay. In the next class, I will solve one more example which has been asked in your model question paper. Till then, keep practicing. If you are not yet subscribed my channel, do subscribe. Thank you. Take care.